morning, everyone, and welcome to the second edition of our All Axes Live event series. I'm Dan Yonka, president of the Mazak Corporation, and I'm joining you today from our iSMART factory in Florence, Kentucky. You know, this may be one of the most technologically advanced factories in the world, one where we've pioneered machine connectivity, factory cybersecurity, lights out unmanned automation, and much more. Like many shops, we realized immediate productivity benefits once we went online with our digital strategy and machine monitoring. We've applied that digital-first approach across the entire Mazak campus, all to ensure our customers have transparent and fast spare parts delivery and technical support. We've been designing and manufacturing machines here in Florence, Kentucky since 1974. Since that time, we've invested in more than 20 expansions. We now have 900,000 square feet under roof supporting engineering, manufacturing, service and parts, and one of our 8 North American technology centers. And we keep investing, including a recent $12 million new 6-machine Mazak palletized automation system. Today, the team here in Kentucky is producing everything from high-value, high-productivity turning and milling machines to the world's most advanced hybrid multitasking solutions, using a fully connected system linked together with smart box technology, smooth production management software, and the power of MT Connect. No matter how complex our facility, however, it's all based on a simple principle, one that has guided this company for a century. We use Mazaks to build Mazaks. Everything you'll see today, most of which is right here in Kentucky, was achieved by using our Mazak software solutions, automation systems, and machine tools to produce your Mazak machines. We don't offer customers any technology we wouldn't use in our own manufacturing operations. That's how much we believe in our technology, and the results speak for themselves. Today, you're going to have the chance to see where the Mazak story began here in the US. But we're also going to show you how you can amplify your shop's productivity and achieve manufacturing success. We'll be visiting one of our newest technical centers in Orlando, Florida, to explore multitasking machine that is ideal for manufacturers who are ready to add automation to their shops. And we'll take a trip to the Oak Ridge National Laboratory in Tennessee for a look at Mazak's hot wire laser deposition technology that literally is transforming the additive manufacturing as we know it. So let's get started on our cross-country journey. Our host today, Thielen Henderson, is here with me in the factory and is going to get things started. So over to you, Thielen.
Thanks, Dan, and thanks to all of you for joining us today. My name is Thielen Henderson, and I'm a product specialist here at Mazak. Before we get started, let's talk about what you can expect from today's All Axes Live event and how you can participate in the event itself. On the left side of your screen, you'll see our library of on-demand machine demos. If you want to check these out at any time, click away. You can always rejoin the main program whenever you're ready. If you've got any questions, you can ask them at any time through the questions window on the right side of your screen. We'll pause for Q&A after each module, and if we don't get to your question on air, a Mazak representative will be in touch soon to make sure you get the information you need. For this edition of All Axes Live, we're taking a cross-country road trip from the Midwest to the Sun Coast. We'll start here in Kentucky before we head down for an exclusive look at the new Mazak Florida Technical Center in Orlando, where you'll see us making chips on the Quick Turn 250 MSY, a done-in-one solution for complete parts and single setups. Next, we'll be back in Kentucky for a quick look at Spindle health monitoring technology and a discussion of how shops are increasing throughput with the HCN-5000 and its multi-pallet pool system, an intuitive, simple, effective, integrated automation solution. After that, we're going to Oak Ridge National Laboratory in Tennessee to see how the Mazak VC500 5-axis hot wire deposition machine is shaping the future of additive manufacturing with 5-axis hot wire deposition technology. We're going to have a great time. But first I want to show you why I'm so proud to be a member of the team here at Mazak. I'm standing here inside one of the most technologically advanced factories in the world, the Mazak iSMART factory in Florence, Kentucky. This facility is nearly 500,000 square feet and it's been expanded 18 times since 1974. And we continually adapt and improve our operations to expand our throughput and be responsive to our customers. A huge part of the advanced machine connectivity we use here, with more than 70 machines networked together through MT Connect and our Mazak SmartBox technology. We use SmartBox technology to gather operator input, Spindle data, and other statistics to generate the daily, weekly, monthly, and real-time reports that chart downtime. We understand why we're experiencing it, and more importantly, what we can do about it. If you can measure it, you can evaluate it, and if you can evaluate it, you can improve. And continuous improvement is here in our DNA in Mazak. It's what drives us and allows us to be responsive to our customers and better cutting chips. That's why we're excited to introduce the newest advancement to the Mazak iSMART factory, our Mazatec Smart Manufacturing Cell. To help explain the impact of this system and how it all works, I'm joined by Kevin Sakarak, our plant manager here at Mazak. Well, good morning, Kevin.
Good morning, Thielen.
So tell me what was in this bay beforehand.
Well, this entire bay was full of 8 Mazak machines, 2 separate Pallitech systems, and 1 material stacker system. But in the past year, we've completed a $12 million expansion. Now we have 6 Mazak machines and 1 full encompassing Pallitech system and 1 supporting material stacker system.
Oh. Footprint, it's much more efficient.
It is. It's about 60% footprint of where we were before, but with more output and less floor space, it's a lot better utilized.
So walk me through the workflow of a part through this system.
It really starts with our production control department and our MRP system. It sends the build schedule down to our system here to prioritize parts. So when a new part comes through, raw material is brought out from a material stacker. Then at the same time, the process stacker brings down the first op fixture. An operator loads the raw material onto the first op fixture, and then it goes into the Pallitech system.
So once it's into the Pallitech system, how does the system know which part to work on next?
That's the beauty of the Pallitech software. The Pallitech scheduling software will prioritize what parts we need the most, and then it finds out what machine is ready for a part. As soon as the machine's ready, tooling's ready, the part is cycled to the machine itself. Once in the machine, then the program to machine the part is downloaded into it, and then it cycles through and cuts the part.
And you mentioned tooling. How many, between 6 machines and 1 tool hive, how many tools are in this system?
Well, each machine itself has 120 tools at least. But then we have a tool transport robot that can take any tool out of any magazine. And since they're all connected, we also have a common tool hive. So total, that's over 1,100 tools that are in the automated system.
That can be used by and shared across any of the 6 machines.
Yes, fully unmanned. That's what we're after. We're going for manned operation to load the parts, but once it's in the Pallitech system, everything's unmanned at that point.
Well, thank you so much, Kevin. So up next, we're going to go down to Florida, where our district sales manager, Perry Leonore, is going to give you an exclusive inside look into Mazak's new Florida Technical Center. Perry?
Welcome to Mazak's new home in Orlando, the Mazak Florida Technical Center, designed to meet the needs of manufacturers from the Sun Coast to the Space Coast. Our new centrally located hub offers the region more access than ever before to the technology, tools, and training required for success in this competitive region, and a comprehensive local support that shops need to maximize their uptime and get the most out of their Mazak equipment. Interested in boosting productivity in the age of high-mix, low-volume manufacturing? Need to learn how to integrate digital solutions to automate traceability documentation? Looking to expand your shop's ability to get the most out of the latest multitasking machine? The Florida Tech Center hosts educational seminars through Mazak's progressive learning programs, as well as training events with industry partners who can provide cutting tools, work holding, and automation expertise necessary to solve the most challenging applications. The Florida Technical Center has training centers where manufacturing professionals can master the digital solutions they need to keep their shop competitive. The pace of innovation keeps getting faster, and to stay competitive, you need to be able to stay in the loop, which is where the Florida Technical Center can help. Our machine and technology demonstration area brings the latest Mazak equipment to your backyard. From simple but innovative turning centers to hybrid multitasking machines, along with automation solutions and digital technology that can take throughput to new heights. But our state-of-the-art technology isn't just for demonstrations. Bring your toughest applications in for a test cut to see how our machines handle your specific part production requirements. But no matter the industry sector, Florida's diverse manufacturing community has to deal with challenges every day. The Mazak Florida Technical Center is designed around helping manufacturers bring together the application specialists, productivity experts, and industry partners they need to develop effective ways to overcome today's biggest obstacles. The team at the Florida Technical Center is ready to help shops amplify their productivity, so call us today to schedule a meeting and discover how we can collaborate with you and your shop in pursuit of manufacturing excellence.
Welcome to Mazak New Technical Center here in Orlando, Florida. My name is Mark Vaughn. I'm an application engineer been with Mazak for over 30 years, working with various different customers. And we're here to show off our QT250 MSY done-in-one machine. This machine has a Y-axis, double slide, 4 inches of travel, plus or minus 2 inches, has a stable bed casting, and it's got 2 spindles. Main spindle is a standard 10-inch chuck with 35 horsepower, got 358 torque pounds, and also it's got a 3.15 through spindle bore for bar. The sub spindle has a standard 6-inch chuck, 15 horsepower, and also this machine has live tooling in a vertical or horizontal position, and also has a parts catcher. Another feature this machine has is utilizing the second spindle for a transfer operation for a first and second op. If you're doing bar work, you can use a cut-off operation also. In addition, you can program C-axis using indexing or contouring down to a 0.001 degree. There's many options available for this model. There's chip conveyor, you got the automatic parts catcher, which I'd mentioned before. You got various high pressure coolant pressures, anywhere from a 213 PSI all the way up to 1,000 PSI using our Mazak Superflow units. You can also automate this equipment with the GR100 gantry robot, which would be picking up your raw material off the pallet, putting it inside the machine, doing your first and second op. The robot would unload it, the finished piece, back onto your pallet table for a done-in-one operation. So now I'd like to show you a demo of the QT250 MSY.
The demo process starts at the 4,000 RPM 35 horsepower main spindle that features a 3-inch through hole for bar-fed stock. The machine is performing various operations such as face-off, turning, drilling, and boring on the front end of the part. Among those operations is milling. Here we see the machine's 6,000 RPM 10 horsepower milling spindle and the machine's compound double slide Y-axis in action. For this demo, the machine also positions the part using its programmable C-axis with 1/10 of a degree indexing accuracy. In addition to these features, the machine comes with an optional rotary conveyor that separates the parts and keeps them damage free. I also like to mention that the QuickTurn 250 MSY is very automation ready, and Mazak offers such options as our GR100 gantry robot with a 2-pallet pitch feed conveyor and Mazak Turn Assist Robot, all of which further boost the efficiency and productivity of the machine.
Hey, Mark, thank you very much for that demonstration. So we do have a few questions from the audience. The first one's going to be, how do all Mazak multitasking machines have done-in-one capability?
Actually, they do not. Usually just machines with a second spindle on there are like a done or considered a done-in-one machine.
And that's because the second spindle allows you to do the back working on parts and drop them off complete?
Correct. Yes, sir.
So now the Quick Turn 250 MSY has a compound Y-axis. What does that mean, and what's that mean for the machine?
The 250 MSY, the compound Y-axis that you mentioned, is a double angle on the carriage, which allows you to actually condense the carriage into a smaller workspace for smaller machines, to use the Y-axis.
Okay, interesting. Well, for done-in-one parts, would I need to hire a 5-axis programmer to run this machine?
Oh, no, certainly not. The QT 250 MSY, you can use Mazak to do a variety of complex parts, first, second operation, and also using a transfer process, to do the first op and second op. Mazak is very simple to use. A beginner machinist can learn this very quickly and efficiently.
Okay, so you wouldn't need to spend time making sure you hire somebody with the right technical expertise and experience.
Correct. No, sir, you would not. Yeah.
We did have one more question, and it's how do we make sure each machine is as accurate as the one beforehand? And actually, for that, we're going to take you to a live demonstration about the aligning of a Quick Turn 250 MSY, and then we're going to continue on to a demonstration for the HCN-5000. So, Mark, I thank you for your time.
All right, thank you.
Okay, I'm Ernest Stahl. Mazak work, do scraping and lining. When I first get this bed, first thing I'll do is check twist and crown. That's to make sure all my linear guide surfaces are parallel. So I'm allowed 5 microns on my twist, 15 microns on my crown. I actually have 5 microns on my twist and 15 on my crown. So we're good with that. If it's bad, if I can't get anything in, then we'll take the bed, send it back, get it remachined. So after that process, everything's good and straight there. Come over here, we'll put these linear guides on. I got this is the reference rail, and this is a straight edge. What I did is I got it set up here so I can make sure this straight edge is, the guide is straight. Run down the side. And I'm within 4 microns, so I know this reference rail is straight. Then what I'll do is I'll go through these other guides off this reference rail, make sure they're all parallel. That way everything is working in line. The next thing I'll do is I have the ball screw here, and with this reference guide good, I'll indicate this ball screw, make sure the height and the side is good. Just check the top here. And the top is parallel with the top of this linear guide, so we're good with that. Okay, now what I'm doing right now is I got to get the center line of the headstock parallel with all my linear guides that we just did. So all that stuff is good, and the way we do that, we put this head bar on, we do the run out, make sure everything's good and straight. That gives me my center line. I go across the top here. I'm about 8 microns plus on top. And what I'll do, down the side, raise up. We go down the side. I'm about 6 microns plus on my side. That way I know by the center line of my headstock is good.
Good morning and welcome to Mazak's National Technology Center in Florence, Kentucky. My name is Jared Like and I'm the Machining Center Product Group Manager here in Florence.
My name is Nathan Vickers and I'm an application engineer here.
All right, first we would like to start off and explain a little bit more about our HCN-5000 behind us, along with our multi-pallet pull system, or our MPP system. We'll start off by discussing a few of the benefits to a horizontal machining center. One of the biggest benefits we see is effective chip evacuation. When you're using a horizontal platform, it's a lot easier for the chips to use gravity to fall, and you don't have to worry about machining over chips like you do on a horizontal or on a vertical machining center. Also, quick tool change time and the number of tools is a large benefit to most customers. Also, something important to note is feed rate of a horizontal machining center. In most cases, is a lot faster than a vertical machining center. It could even be twice as fast. Next, I'm going to talk about some of the available options on this machine to increase your productivity. These machines, the HCN-5000, come standard with a 12,000 RPM spindle and 40 tools. As shown here, we have our 14,000 RPM high torque spindle along with 120 tools. Our spindles come in Cat 40, Cat 40 Big Plus, and HSK 63 options. To dive a little deeper into our tool capacity options, we offer a 40, 60 tool drum. We also offer an 80, 120, and 160 tool chain magazine. And then we offer a tool hive options where you can have 204, 240, 288, 312, or 348 tools. These tool hive options are expandable up until 348 tools. I also want to mention the spindle options on this machine. As I previously stated, this machine has our 14,000 RPM high torque spindle. This spindle is 50 horsepower and has a max torque of 223 foot-pounds. We also offer an 18K spindle for aluminum and non-ferrous materials, which is 47 horsepower and 124 foot-pounds of torque. A few other machine features I'd like to point out is we offer a 1-degree table as standard, which you would have 360 positions. We also offer a full NCRT, or rotary axis. Our rotary axis, our B axis on this machine, uses a roller gear cam design. And I would also like to point out that our max pallet load is over 1,500 pounds. Another important feature of this machine is the 4-cone clamping on the table. So our table clamping is over 16,000 pounds of force. So this allows you to machine very high in the Y or very low in the Y, and you still have the same rigidity. Also, it is important to note the chip-to-chip time and the weight pocket that is associated with our tool chain magazines. Next, I'd like to talk about some automation options that we have to help increase your productivity. First, I will talk about single machine automations that Mazak offers. First and foremost, we have the 2 pallet changer. This is a very simple form of automation, but this can drastically help you increase your productivity and spindle utilization from a traditional vertical machining center. We also offer a 6 pallet changer and the multi-pallet pull system, which is behind me. I will get into more detail on the MPP in a few minutes. We also offer automation systems for multiple machines. These would be the Mazak Paletech systems or Mazatec SMS. You've seen the Mazatec SMS earlier in our Kentucky production facility. Our Paletech systems are great linear systems and can have multiple machines or even different types of machines. So on to a little bit more about the MPP system behind me. A very nice feature to this MPP system is it's all ran through our Smooth G control. There is not a separate cell controller, and everything is made and manufactured by Mazak. Another important feature is the floor space. If you do not have room for a long linear system, or maybe you only want one machine automated, the MPP is a great solution. The MPP behind me has 10 pallets, but also has the ability to be expanded to 16 pallets. So it is a 2-level system. Now going into the specifications of the MPP behind me. So your max workpiece diameter is 31.5 inches, the same as the machine. And also your max workpiece height is 39.37 inches, the same as the machine. We also are able to have the 1,543 pound load capacity on the pallet in either the first level or the second level MPP, which is the same as the machine. Next, I'll turn it over to Nathan.
So let's switch gears and talk about the live demonstration. The part that we are machining today is a prototype of a cylinder head. We have 4 main ops utilizing 4 pallets and fixtures. There's a total of 29 operations to complete the part. Let's go ahead and take a look at each of the op a little bit closer.
Here you will see the robot going to the loading station to pick up the Op 10 fixture. The robot will pivot around and place this fixture into the pallet changer of the machine, ready to be cycled in.
All right, as mentioned here, this is our Op 10. First operation that we're going to be seeing here is a facing operation. We're using a 3-inch face mill. Next up here, this is going to be the undercut for the dovetail on both sides. We're using a 1.75-inch dovetail cutter.
Here you will see the pallet coming out of the machine for Op 10. And this is a reminder that this is one of 10 pallets on this system.
Okay, so this is our Op 20. This is going to be our rough and finish of the OD profile. Here we're utilizing a 1-inch end mill, full depth of cut, taking light radial cuts. This here is actually one of the finishing passes. Next here we're drilling the 4 portholes. We're utilizing a 1.25-inch special port drill. We're drilling this in one Okay, so next is going to be rough and finishing the side relief. Here we're using a 6mm end mill. Fairly high speed application. All right, so here we went ahead and switched the pallet. We are now on Op 30. We're drilling this long 8-inch hole. We already drilled 1.5 inches with our short drill, and now we're just chasing that, finish out that 8-inch long hole. So here is the jump to Op 40. This here we're roughing our cavity with a 10mm end mill. Next here we will be utilizing a 6mm ball to finish the cavity. And lastly, we are going to be chamfering the OD edges utilizing a 1/2-inch chamfer. That concludes our live demonstration. We look forward to answering your question in the Q&A session.
Jared and Nathan, thank you for that demonstration. That is some powerful and intuitive automation. We do have some questions, and listen, if we don't get to your question on air today, again, a Mazak representative will be in touch with you shortly to make sure that we get you all the information you need. First, Nathan, what cam system was this programmed in?
So all 4 operations or ops were actually used with a spree cam. Their newer version TNG.
So, Jared, I'm going to ask you this. Why would I buy an MPP system versus a pallet deck?
Well, I think an MPP system is great for a customer that might have floor space requirements.
Yeah.
Maybe to try to tuck it into a smaller area. And if, they don't think that they will ever automate with multiple machines in the future, if they just want to stick with a smaller scope automation system.
Okay, so an MPP system reduces floor space and is more versatile for options like adding other machines.
Correct, yeah. The MPP systems just used for one machine, whereas Palatech, you can add multiple machines to it.
Right. Yeah, thank you. So, and Nathan, what's the average pallet change time of the MPP system?
So that's a great question. So it depends on where the pallet is coming from and going. For example, if you're moving a pallet to the load station, it's going to take a little bit longer due to the safety door opening and closing.
Yeah.
However, if you're picking up a pallet and you're moving it to the machine, you're looking about 8 seconds. Okay. Now, keep in mind that you can preload pallets in the backside of the machine. So when it's time to rotate the finished pallet out, you already have that next pallet rotating and ready to go.
Hey, great. Well, my thanks again to Jared and Nathan. Our next stop will be the famed Oak Ridge National Laboratory in Tennessee, where we're going to see Mazak's hot wire deposition technology in action. But before we check with Tom and Dave at Oak Ridge, take a few minutes to learn about Mazak's Spindle health monitoring technology with Joe Sanders.
Hi, I'm Joe Sanders with Mazak Sales Engineering. I would like to talk to you today about a new product from Mazak in partnership with the University of Cincinnati IMS Center, which offers our customers the ability to monitor the health condition of a machine spindle called Spindle Health Monitoring. As we all know, a machine that's not making you chips is not making you money. Especially in today's world, when the current pandemic, scheduling someone in, and if they're even available to come into your facility, it has its own challenges. The integration of this system in your Mazak machine makes it smarter and gives it the ability to self-diagnose faulty conditions within the spindle bearings before complete failure occurs. This spindle health monitoring system allows you to see the percentage of life left within your spindle and gives you the ability to schedule downtime for the proper maintenance to be performed. This minimizes the machine downtime and increases productivity, which in turn increases profits. The spindle health monitoring system components consist of a spindle vibration sensor, a spindle drive current sensor, DAQ module, industrial edge computer, which are all integrated within the machine. Each machine has a unique spindle signature that is mapped using AI functions to capture that unique fingerprint. From there, the spindle signature data is normalized, cleaned, segmented, and features are extracted. Using the extracted features and the data is analyzed through machine learning algorithms which create a health assessment of the current spindle condition, and any fault diagnosis can be viewed on the Spindle Health Monitor dashboard. The dashboard can be viewed on the machine control directly or any device connected to the same network through the standard web browser application. When multiple machines are equipped with the system, the multi-machine dashboard is available to monitor the machines simultaneously and as long as they're tied into the same network, as you can see here. Once the system is installed and the spindle signature is captured, all that is required to check the current spindle health condition is to run a 60-second fixed cycle free running test macro with this balance tool that was used to capture the original signature. The health assessment looks at 3 main fault conditions, which are spindle balance, bearing health, and temperature. A percentage of spindle life left is determined from the data and displayed on the dashboard from there. The machine owner can choose to run this test as often as they see fit, but the more often the spindle test is run, the more accurate your spindle health assessment will be. Behind me is a practical example of the Spindle Health Monitor multi-machine dashboard, which is connected to the Mazak SMS6 machine cell that Teal and Kevin discussed earlier. The system is currently monitoring the health condition of 2 HCN-6000s, 3 HCN-8800s, and 1 Integrex E1250. From this display, we can see the percentage of life left of each of these machines without actually having to go to the individual machine. which takes time out of your day. The health condition is automatically updated on the display once the test macro is complete, and each machine can be selected individually to see the more detailed fault analysis. This dashboard can be viewed on any computer within the same network, on your personal computer, or at home with so many people working remotely today. As you see the spindle degrade from 80%, you'll see the display change from green to yellow, which indicates it's time to start keeping an eye on this machine. Once the spindle condition drops below this 20%, the machine turns from yellow to red, which shows that it needs immediate action and there's a serious fault condition occurring. Currently, the spindle monitoring system is offered on various machine models and development is ongoing with multiple different machines. If you have any questions about this system, please contact your Mazak salesman, and thank you for your time.
Hello, and welcome to the manufacturing demonstration facility here at Oak Ridge National Laboratory. My name is Dr. Tom Feldhausen, and I oversee hybrid research manufacturing here at the National Laboratory.
My name is David Wilson. I'm an application engineer and Mazak's liaison to Oak Ridge National Laboratories. Mazak has teamed up with Oak Ridge to develop and enhance its industry-first hot wire laser deposition hybrid technology. The prototype of this joint effort is the machine that you see behind us. This is the Mazak VC500A 5X HWD. It was designed and built in Florence, Kentucky, and it is the first hot wire laser deposition hybrid machine to the market. This machine has a work envelope of 500 millimeters in diameter by 300 millimeters tall, and it comes equipped standard with a 25 horsepower, 12,000 RPM 40 taper spindle, as well as a 4 kilowatt fiber laser deposition system capable of up to 10 pounds per hour in steel.
In a single setup, we can deposit virtually any ferrous material. We can then machine the deposited geometry with full 5 axes of motion. The ability to perform both additive manufacturing and machining operations in the same envelope allows us reduced cycle times, significant material savings, and improved dimensional control of internal geometries compared over traditional manufacturing techniques. You'll recognize the component we're building right now as a marine propeller. Mazak's hybrid process is ideal for complex geometry such as this because it eliminates the need for costly, long lead time casting processes to create the near net shape. The integrated capability allows us to interleave the additive and subtractive processes to help minimize manufacturing material and tooling costs compared to traditional manufacturing techniques. Furthermore, the material utilization rate of this deposition process is in excess of 90%. This results in drastic material cost reductions when processing expensive, exotic alloys that are often difficult to machine in the first place.
Another application where the hot wire laser deposition process excels is cladding operations. We can efficiently deposit dissimilar material resulting in a layer of harder or more wear-resistant material on a cheaper or lighter substrate, and then machine the material back into net shape in the same setup. This makes the process ideal for the production or repair of bearing surfaces, valve seats, pump bodies, and other components with small, critical areas of high wear. We've already seen some success cladding Stellite 6 on a 410 stainless steel substrate for a hydraulic valve application in the maritime industry. The operations do not always have to be dissimilar. The VC500A 5X HWD machine is ideal for repairing worn or damaged high-dollar components, such as injection molds, punch and die sets, yokes, gear teeth, and other power transmission components, and even turbine blades.
This machine is also very user-friendly. The additive toolpath can be easily programmed with your preferred CAM software suite using the same G-code language that all machine tools use. Build process parameters such as laser power, wire feed rate, and wire preheat power are all adjustable in situ, just as you might use the feed or spindle override to adjust machining operations. Mazak's SmoothX CNC provides powerful processing for all machine functions, and of course it comes equipped with Mazak for machining operations.
Other additive processes in the industry, such as powder, typically rely on resolution to achieve net shape of components. The smaller the bead of deposited material, the higher the resolution, doing it to be able to build to net size. With Mazak's laser hot wire deposition hybrid technology, we can sacrifice resolution in favor of speed and then finish the part with our 5-axis machining capabilities. As a result, we can build up to 20 times faster than powder processes and have more control over surface finishes and characteristics. The Mazak VC500A 5X HWD can easily and quickly change between materials with the operator only needing basic shop PPE. And when compared to metal powder, welding wire is significantly cheaper.
My team and I here at Oak Ridge National Laboratory are proud to say we have the very first Mazak hot wire laser deposition hybrid machine. The team and I work alongside David and Mazak's team of engineers every day to enhance this new technology at the National Laboratory. We focus on finding new applications, expanding processing strategies for new materials, and develop qualification techniques for components manufactured by hybrid technology.
And Mazak is proud to partner with Oak Ridge National Laboratories, one of the nation's leading manufacturing research facilities, to develop this cutting-edge hybrid technology. Let's take a closer look now at the demo that we prepared for you.
So here at the National Lab, we have a lot of industrial collaborators. So not only do we work with Mazak, but we work with the leading cam manufacturers in the industry, such as Opermind's Hypermill and Autodesk's Fusion 360. Now this specific demonstration interleaves both the additive and the machining operations in a single push-button process is shown here.
And speaking of industrial collaborators, Mazak and Oak Ridge didn't develop this technology all on our own. The 4 kilowatt additive system was developed in conjunction with Lincoln Electric. The laser itself is generated from a 4 kilowatt fiber laser made by Enlight Corporation. And the focus is all taken care of in a laser mechanical Fiber Mini 2.0.
Now for this demonstration, even though it's a fairly small marine propeller shown here, we're depositing 316L stainless steel on top of 316L substrate. Now with this, we're only doing one additive and one machining operation, yet it's still using a push-button process. And when we expand this, like we've done in the past, David, when we look at very large marine propellers, we could start interleaving the two processes together. Because when we look at very large marine propulsors, they become very difficult to machine. You need a lot of reach and access. But when we interleave the two processes together, we can actually go between the additive and the subtractive process without having to move the part and refixturing it. And we can have improved reach and access, allowing us to machine these very complex geometries very easily.
By interleaving the processes, not only do we give ourselves the ability to reach tighter internal geometries, which would otherwise be difficult to machine, we also give ourselves a significant material savings over traditional processes, which would be a casting operation to achieve near net shape and then machining of the finished component, or machining the entire finished component from a piece of billet stock. The lead times associated with casting processes are typically very long, with a lot of specialty equipment involved, and your choices are very limited. With machining from a large piece of stock option, obviously you have significant increased material costs, increased tooling costs, and it's a lot harder to process more internal geometries on the component itself.
That brings up a very good point, David, and that really highlights a lot of our collaborative work here at the National Lab, where we really want to demystify the additive process. A lot of the things we're doing, as we talked about, being able to change various processing parameters in situ allows us to further make this process a push-button process, such that we can democratize this manufacturing technique such that all industrial users can utilize hybrid manufacturing's abilities.
I feel like additive manufacturing can be very daunting for a lot of traditionally subtractive manufacturing shops, things like that. This process that we've developed really makes it very easy. A capable machinist can run this machine. You don't need to be a material scientist or even really a welder to do it. Like you said, push button. You can program it with your choice of CAM software, just like you would program anything you've programmed in the past, and it operates similar to any other Mazak machine. That concludes our demonstration, and we look forward to taking your questions in the live Q&A coming right up.
Guys, thank you. We're just getting back. Thank you so much for that presentation. Additive manufacturing is just always so fascinating because I'm so used to subtractive. We do have some great questions. So first off, Tom, I'm going to ask you, or Dr. Feldhausen, I'm going to ask you, how quickly does Oak Ridge go from prototype to production?
That's a great question, Thielen. So here at the National Lab, we've done a lot of demonstrations from going to prototype to production at the order of days to weeks. A great example of something we did last March with the Mazak hot wire machine. We were able to generate a steel injection mold to injection mold face shield for COVID-19, and with it, we were able to do it in the over the course of 4 to 5 days. Go from initial design to a final production mold.
Wow, 4 to 5 days is impressive. David, I'm going to ask you this next one. How close to near net part shape can you get with this machine? Is there a limit to how small you can get for a feature?
Well, with our additive capabilities, you'll notice in the demo we talked about sacrificing resolution for speed. The bead that we put down is generally about 5 millimeters wide by 1.7 millimeters tall. So the smallest part that we can build is that big, but the beauty of our machine is it's integrated into a 5-axis machining platform. Therefore, that small feature can be milled down to basically an infinitely small size, as small as you want to go.
Got it. And that's what we mean when we say hybrid machining. You know, it's a combination of both additive and subtractive together.
Absolutely. The ability to interleave the two in the same setup.
Interesting. Dr. Feldhausen, could you describe machining a part while it's still hot?
That's a really good question, Thielen. So that's really interesting to us here at the National Lab, because if we have to wait for a part to cool down, that's a lot of downtime that can be very costly for a production center. So we want to make that transition as fast as possible. So we've done some initial studies just using standard tooling that we get from Kennametal off of the shelf. And with that, we see little to no effect to the final part quality with regard to geometry as well as material properties.
Oh, wow. And what does that do to the tooling?
We see little to no wear in the tooling, since you have to remember when we switch to the machining operation, there's a 3 to 4 second delay. So the chips actually generating are hotter or have a higher temperature than the actual part. So we see little effect.
Thank you. David, how much training is needed for a machinist to learn the hot wire deposition side of the machine?
Well, the interface for the hot wire side of the machine is actually remarkably simple. Any decent machinist would be able to step up to this machine and with minimal training be able to figure it out.
So if they're capable with the subtractive, learning the additive is really not that big a jump.
Absolutely, not a problem at all.
That's great. All right, well, hey, gentlemen, thank you so much for your time today. That is just some really cool technology. So we're coming to an end of our time together today. But before we close, let's take a quick look at the wide range of hybrid technology Mazak has to offer. It's amazing what you can cover in a little over an hour on a cross-country virtual journey, isn't it? In just a short time, we've seen a lot, We've learned how the new Mazak Florida Technical Center can help local manufacturers improve productivity. We've explored a wide range of machine technology, from our workhorse Quick Turn 250 MSY that makes done-in-one a reality, to the high-performance HCN-5000 equipped with our space-saving multi-pallet pool system. We've learned how Spindle health monitoring reduces downtime, not to mention that amazing demonstration of hot wire deposition technology with our friends at Oak Ridge National Laboratory in Tennessee. Finally, we've shown you how we use Mazaks to make Mazaks right here in Florence, Kentucky every day, and hopefully given you some ideas about how to improve your own productivity. And while we have indeed covered a lot of ground today, there's so much more to see. The archive of today's event will be available immediately following the event. So if you didn't have time to watch all the demos that caught your eye, you can log back in at any time to check them out. You can visit our website for more information on the technology you saw today, or contact your local Mazak representative. Be on the lookout for the next All Axes Live event, which is scheduled for October. Exciting new things coming with this one. I can promise you won't want to miss it. Be on the lookout for an invitation to join a new private LinkedIn discussion group for your region, which will be a great place to continue the discussions we've started here today. As you saw today, our Kentucky factory, 8 regional technology centers, and 4 technical centers are all open and fully functional, operating with all the necessary safety protocols in place. Please contact your Mazak representative today to schedule your visit. Thanks again for joining us on our cross-country journey today, and I'll see you next time all on All Axes Live.